has synchrotron radiation facility at Indore, which is known as Raja Ramanna Center for Advanced Technology, RRCAT, very well known, and they have constructed two beams. One is Indus 1, which started first, and then Indus 2. In this figure, you can see that Indus 1 and so microtron is there for producing the beam, and then after that you can see the booster, which is at 550 MeV, and then okay. And you can see the Indus 1 which is having 450 mega electron volt, the energy. You can see we are taking it keV and here it is MeV, and the current is 100 milliampere, whereas with the traditional sources we hardly get 10-20. And from the same beam they have constructed Indus 2, and there you can see the energy 2.5 giga electron volt, and as well the current is 200 milliampere. With the traditional sources maximum we can get 20 or 30. You can just see Indus 2 ring. This is the storage ring you can see in the first one, and these are the components assembled inside the Indus 2 ring. These are the solid state amplifiers, 1, 2, 3, 4 you can see here, and in the third figure you can see the front side of the synchrotron radiation source, and you can see inside the experimental hall you can see the people who are working. So there are certain stations which are made for experimental arrangement. So the maximum flux you can see which can be obtained and at what photon energy. So that curve is showing that energy is 2.5 GeV, and the circumference of the ring is 173 meter. Somebody was asking me that, sir, what is the size of the synchrotron radiation source? So you can see that circumference is so much big of the storage ring as well, and this is constructed in several kilometers, the building. At present the operational beam lines at Indus 2 are for soft X-ray, X-ray imaging, soft X-ray reflectivity, lithography, our dispersive exafs. You can see the range is 5 keV to 20 keV, which is still less for us. Scanning exafs and XRD under extreme conditions, angle dispersive XRD, hard X-rays, X-ray fluorescence, and protein crystallography. So these are the beam lines available at Indus 2 for different characterization, and all these facilities exist there. So anybody interested for doing the exafs can use the different beam line. Anybody interested in XRD can use it. Some of you have already visited there, so you know better than me. They are under installation beamline for engineering applications, that is beamline number 2, and the range will be 5 keV to 25 keV, and grazing scattering X-ray, the beamline number is 13, energy will be 4 keV to 25 keV, and beamline number 18 will be for small and wide angle X-ray scattering. These beamlines are still under design, soft X-ray, radioactivity, multi-investigation of radioactive actinides, photoemission electron microscopy. So these are beamlines under design and construction. The devices existing there under the beamlines are just shown here, the beamline 5, 10, 15, 20, 25, and these are the beamlines, and the devices available there are superconducting wavelength shifter, helical undulator, multipole wiggler. These are the devices attached with these beamlines. Energy range is approximately 5 to 250 in the first case, and as low as 5 to 20 kilo electron volt for protein crystallography. This is U1, U2, U3. You can see these devices are inserted there in the beamlines. This is the experimental station of the beamline. This is the Indus 1 hall with different beamlines. You can see that beamlines are coming from there. This is the ring almost, and these are the beamlines at different places. You can see 4 beamlines here. You can see the flux is almost same, and but energy is very less, 450 MeV here. Now they have constructed 2.5 GeV. Beamlines available on Indus 1 are soft X-ray, angle integrated photoelectron spectroscopy, and vacuum ultraviolet spectroscopy, infrared, and they are also constructing one beamline on photo absorption spectroscopy. The range will be 100 electron volt to 800 electron volt. This is the schematic diagram for beamlines, different beamlines at RRCat. You can see Indus 1, that is circular, not rectangular one. You can see beamlines available there, and Indus 2, which is circular. So you can see that number of beamlines are available, and for any queries you can contact them. You can see the facilities provided by the RRCat, the train fare to JRF and SRF, and travel support for the young faculty they provide. Guest house accommodation is available there, and I am very happy to say that their guest house is excellent. The number of days available or number of days utilized in 2016-17, you can see that for 5,300 hours they have used the Indus 2, and 7,100 hours for Indus 1, and it was operational for 337 days in 1 year. You can see almost every day it was working, except for about 1 month, that maintenance period. and you can see the users and the number of experiments. It is increasing day by day. In 2016, they have done 639 experiments, user experiments, and which was very less as in 2014 it was only 230, and they have given the data in first 6 months of 2017. Experiments were carried out about 375. And here you can see the publications, which was only 78 in 2014, and in 2017 up to June they could publish 130 papers. These are some relevant details of the facilities available at Indus, which is of our interest, X-ray absorption spectroscopy. So you can see again same, the detector, the sample is there, fluorescence beam, and the transmitted beam is recorded as IT. So this is the setup of EXAP. And this is for the hard X-ray region. You can see 4 keV to 25 keV. They have Beamline 9, and also the Beamline 8 is for hard X-ray region, whereas Beamline 1 is for the soft X-ray region. And there you can do the both the beam lines, you can do the fluorescence as well as transmission. This is Beamline 1 for soft X-ray. As you know, the wavelength is very less, so energy is 100 to 1200 electron volt. So Beamline 9, which is for 8 and 9 for hard X-ray region, the facilities available are low temperature up to 10 K, high temperature is up to 1000 K, and both measurements are possible, transmission mode as well as fluorescence mode. And thin films also you can record using the goniometer. In situ studies of reaction of kinematics. Gas chromatograph is also available, and you can contact to RRCAT. And in Beamline 1, which is soft X-ray region, measurements can be done for ultra high vacuum and for RF sputtering and X-ray absorption spectroscopy. XMCD measurements are also possible. X-ray diffraction, some of you were requesting about the X-ray diffraction facilities. So these are the central facilities available to all of users there at RRCAT, and Beamline 11 and 12 are dedicated for XRD. This is the goniometer setup, and you can see that with applications of XRD you can do the crystal structure, atomic positioning, phase of the materials, particle size, stress strain, all of you know. We can measure quality of single crystals. Protein crystallography is not my area of research, but the facilities I am just showing, they're available there. You can see Beamline specification are there, and single crystal diffraction is possible, SAD, MAD, single crystal and powder diffraction. X-ray fluorescence microscopy, which is different from our X-ray absorption. Beamline 16 is dedicated for Indus to for fluorescence. So you can detect the elements, the trace elements in ppm level, and mapping can be done in the 4 micron to 7 microns. This is just the picture they have shown, the facility they have shown, and these are the elements you can detect there using the fluorescence beam. Soft X-ray, you can see the region, infrared visual. The soft X-ray region is very large, as you can see, from 100 electron volt to 1500 electron volt. And so in Indus 1 as well as in Indus 2, both they are facilities are available. This range was very less, 10 electron volt comes out to be in the hard region, whereas this is fairly large region. Photoelectron spectroscopy is also available there. 2 beam lines, Indus 1 and Indus 2 is the beamline 14 for photoelectron spectroscopy. X-ray based imaging is also possible. You can see the X-ray absorption imaging, phase contrast imaging, microtomography, and laminography, which is basically in the 3D. So this facility is again available there. X-ray lithography in beamline 7, and you can see the parameters there. This is what I received from RR-CAT Indore. I thank to them for providing this slides to us, just to show the facilities existing over there. So with this, we come to the end of the session, and we have time for going to the photograph at 12 o'clock at MP Hall. Those who are from here, they know MP Hall. You can follow them, and we will have a group photograph there, and after that the evaluation will take place here only. And I expect that you will not use your mobile phones for that. No help from the your data available or whatever notes you have taken earlier. Okay, so let us stop it here.